Right, guys, so we're going to pull at the top. Obviously, x squared minus 2x minus 15. We look for factors of 15. The difference between them must equal negative 2. So I'm going to do x minus 3x plus 5. Do we agree with that?
Mine 5 was 3.
Oh, mine.
Yeah, mine is 5.
Yes.
Yeah.
I was chasing you guys. Well done. Passing my test. X plus 3. X plus 3, x minus 5. All right. 4, you're getting marks in my mind. Okay, I'm gonna. But now you. Okay, minus 3 over x squared minus 9 is x plus 3, x minus 3. There we go. I can do that one at least. But I don't want you to think that we're not going to take it out of the common bracket or something funny. So guys, remember when we obviously subtracting fractions here, all right? One fraction from the other, so we need to write them both over the LCD. Now, do we see that these denominators are obviously more complicated than the ones that we did on Thursday, right? Now we not only have numbers and like x's and y's, we actually have brackets. Okay, so yes, we do have a common bracket. So x plus 3. Now remember guys, the LCD is something that in this case both of our denominators can divide into. So does it make sense that x plus 3 must be in the LCD? Yes. Do I need 2 x plus 3? Let's just think quickly. If it was an x and an x, what would my LCD be? Just x, right? So if there are 2 of the same brackets, that bracket only needs to be in your LCD once. Okay? Then what other brackets do I have? X minus 5 and x minus 3. So guys, the LCD in this case is going to be those 3 brackets. X plus 3, x minus 5, x minus 3. All right. So we don't double the repeated bracket. I'll just write this on the side. The LCD is x plus 3, x minus 5, x minus 3. Sorry, now obviously I need to move the page around a lot because it's zoomed in quite a bit. All right, that is the LCD. Guys, it's just like when you have a 2 and a 2, your LCD is not 4. Your LCD is still 2. You understand? Right? Because 2 will go into 2. All right, so even though we have a repeated bracket, we don't repeat it in the LCD. When would I have to put an x minus x plus 3 squared in the LCD? When would they have to be a squared outside that bracket? If there was actually an x plus 3 squared in either one of these 2 denominators, right? So if that was x plus 3 and this was x plus 3 squared, then you would have to have an x plus 3 squared in the denominator. Okay, so you need to include all the different brackets to their highest exponents, but you don't repeat them if they are repeated in the denominator. Okay, now remember what we now need to do. Sorry that the LCD is out of sight there, but we will move across just now. We now need to look at this denominator, and remember guys, this is an expression, okay? So we need to figure out what does I multiply the denominator by to turn it into the LCD. Now I have an x plus 3, x minus 5, so I need to multiply it by x minus 3, right? Then I will do the same thing at the top. Do you remember this? We did similar ones on Thursday.
We have to pull.
Okay. No, you don't have to. It helps if you do. Okay, and now for the second denominator, I have x plus 3, x minus 3. Which bracket is missing? X minus 5. So that is what I need to multiply the bottom by. And then since it's a fraction, whatever I do at the bottom, I have to do at the top as well. What if I multiply this by to turn it into the LCD? X minus 5. So I do the same thing. I just make sure that you see that there's like a, that's not one thing, okay? Okay, so now both of my denominators will turn into x plus 3, x minus 5, x minus 3. So I can now go over one fraction. That's fine? So at the top, I need to just do that multiplication. I'm going to do 4 times x minus 3. And now because there's a minus in between these fractions, it needs to be negative 3 times x minus 5. You could have multiplied those brackets out straight away if you wanted to. It's the first example that we're doing of this kind, so I am just taking it slow. And there we have the LCD. So guys, am I not allowed to say, oh lovely, there's an x minus 3, let's cancel that one. No, we have 2 terms at the top, right? And can I say that x minus 5 and that x minus 5 and we cancel out? No. What? No. Okay, fine. So we're not allowed to cancel out. So what can I do? Multiply out. All right. So 4x minus 12 minus 3x plus 15. Is that correct? Over these 3 brackets again. Then I'm going to get the nice simplify that numerator. So x minus 3x is 8. And that's negative 12 plus 15. Plus 3. So I'm going to get x plus 3. That's quite nice. So we're going to get x plus 3 at the top. All over. Oh, I feel like that line is a bit long. X plus 3, x minus 5, x minus 3. Is that the final answer? X plus 3, x plus 3. Now, guys, I can't cancel that off because I'm actually canceling out both terms. All right, and maybe we can also put brackets around those 2 terms if you want to turn it into 1 term. So feel free to do that. That makes you feel better. All right, so then the x plus 3 and the x plus 3 will cancel out, and we are left with, at the bottom, x minus 5 times x minus 3. Nope. And 1 over, like I said in 4 as well, we never have to multiply these things out, unless in multiplying out, it allows us to simplify. All right, that's my answer. Okay, let's try one on your own.
Everyone's very tired today.
It's your guys, if you knew the grade 8 lesson that I had today.
We can call 17. What happened when you're grade 8?
Yeah, I see what you're doing now. I'm seeing straight through. It was just rough.
I think you can tell us now.
How do you know the explicit detail?
Okay, number 2.
Maybe you can explain why we do this math stuff.
It's just entertaining. We will promise to do it.
I want you to do this one. Thank you. I'm just going to freeze that so that I can draw my lines without just frozen the screen so that my ruler is going away. There we go. Okay, guys, simplify that one, please. Now, what I just want to say, obviously, you're going to have to factorize your denominators, right? And the reason why we do that is so that the LCD is not terribly complicated. Okay, if we maybe I should just go through because I didn't actually lead you guys into why we are factorizing, we just did it. So let me just go back quickly. Right, if we're looking at these 2 denominators, right? And this is a very common mistake. In grade 10, even in grade 11, even in grade 12. Where if people have to add these or subtract these in this case, they just say, okay, these are 2 different denominators, so the LCD is going to be this in a bracket and that in a bracket. Okay, you see what I'm saying? So people will say the LCD is x squared minus 2x minus 15, x squared minus 9. But then what they do is they now times by x, and you end up with an x to the 4 somewhere in the mix. It gets very, very complicated. Now, sometimes most people, they actually get the right answer, even if they do that. But you will be complicating your life very much, all right? So if you are seeing something like this, and I think in this case, it was very easy to see, oh, this is obviously a trinomial, right? This is obviously a difference of 2 squared. So let's factorize them. But guys, the reason for us actually factorizing them is so that when we are getting our LCD, like we saw that we had a repeated bracket here. And the fact that we didn't have to have that bracket twice actually simplified our working when we were multiplying out and so on. So let's maybe just add a little note here on the side. Sorry, I was excited to get going. I was just like going for my apologies. I'm just going to say here on the side, factorize the denominators before finding the LCD. But I promise you guys, it will make the actual multiplying out and getting to the final answer much simpler. You guys, most of you are quite good at algebra, so you could probably still get the right thing, but it's by the simplest way. All right, so whenever you are doing a question where you have to find an LCD, because you're adding or subtracting a fraction, just like when we times and divide fractions, let's also factorize just to make the actual working simpler. All right, so factorize the denominators before you actually find the LCD. All right, everyone write this down, please, and I'll go back to the question that you must do now on your own. Okay, now for this one, in the first denominator, we can't factorize that, right? It's just an x minus 1. What do we have in the second denominator? The difference of 2 cubes. We can factorize that, right? But we can actually also factorize the numerator, right? Sometimes when you factorize the numerator, you might be able to simplify within that same fraction. Okay, in this case, that won't happen, but if you do something like that, an x squared plus 2x, you can take out an x as a common factor and see if it helps, all right? In that last fraction, that denominator, that trinomial, can we factorize that? Factors of 1, right? I'm working backwards. Factors of 1, when we add them, it should give us 1. You can't do that, right? Because factors of 1 would be 1 and 1. And if I add them, I'm going to get 2. So guys, this is a trinomial that we cannot factorize. Right? You can carry on. See what happens. You're going to have to factorize a little one, basically. I mean, what you can do in terms of your LCD. So maybe we're trying to get repeated brackets rather, so that our LCD is simpler. Yes. So you're not going to cancel them. Yes. We just had this conversation. That's all right. Yep, because you're adding them, right? Subtracting, so you have to write them all over the same denominator. Yes. Yes, because of that. See, so it doesn't have to be a part. Yeah. Okay, guys, I'm just going to give you a hint here. I'm not sure if you have been doing what I'm doing. Look at that line there, right? Should we factorize 1 minus x cubed like this? Let's just revise that quickly. You see that it's a difference of 2 cubes, so you say the cube root of 1 is 1. The cube root of negative x cubed is negative x, right? Then you use that to get your second bracket, so 1 squared. If you multiply them together, it's negative x, and you change the sign, and then you square that one, you get x squared. Now, guys, do we notice that these three terms are the exact same? Right? They're just written in a different order, but that's fine. If they're all positive, you can just change the order, right? So these two are actually the same brackets. But what's happening here now, guys? I have an x minus 1 and a 1 minus x, and yes, they are different brackets, but you see that if you do a switch around, by saying that plus 2 minus, you can change the 1 minus x to an x minus 1. Why would we want to do that? Yes, because I already have an x minus 1 bracket in the first term. And if I have an x minus 1 and an x minus 1, I only have to have one x minus 1 in my LCD. Compared to if I leave it like this, my LCD has to be x minus 1, 1 minus x, x squared plus x plus 1. Okay, so we want to change whatever our original denominators are, whether that's by factorizing them, by possibly doing a switch around. We want to change them in such a way that the LCD will be as simple as possible. Okay, now guys, what happened here, this is what I meant when I said just try it and see what happens, right? You don't have to do this. You can maybe also just visualize already that it's not going to help you to cancel out this, to take out this x. But I just did that just so that you could see you are allowed to do this, right? We just try things out. So I'm taking out an x as a common factor, but does that allow me to cancel anything out in the denominator? No. All right. So then you can multiply that in, or you can leave it factorized. Doesn't matter. It's up to you. Okay. Now from here, we can see that the LCD is quite manageable. It's just going to be x minus 1, x squared plus x plus 1. Just those two brackets. So we have two x minus 1 brackets, and we have two x squared plus x plus 1 brackets. All right. Neither of them are squared or cubed or whatever, so we can just have the bracket as it is. I'm just going to write on the side. And you don't have to write that down because it is a good idea, maybe just to write it down so that you are always aware of what you're working towards. Okay, the LCD is those two brackets. Okay, now we need to multiply each denominator by something to turn it into the LCD. So for the first one, I'm going to multiply by the trinomial. All right, do we agree with that? So the first one is just x minus 1. So to turn it, basically, this is my LCD. So to turn it into this, I must multiply it by that trinomial. So again, this you don't have to write in, but you can if you want. Let's do the same thing at the top. For my second term, do I have to do anything here, guys? My denominator is already the LCD, so I can keep this numerator as it is. I don't have to multiply by anything. Just remember, please, this is important. Maybe you want to circle this minus. when we put all of our numerators together as one numerator, we're gonna have to subtract this entire numerator. And that's also a very common error that people just do minus and then they just write x squared plus 2x. You're gonna have to put that x squared plus 2x in brackets. Because we have to subtract the whole numerator. Okay, that's important. So maybe put brackets around that. That will help you remember. So the last one, I need to multiply this by x minus 1. And then the top also by x minus 1. Okay, please guys, you must speak up if you're feeling lost. Alright? Or you must come chat to me afterwards. It's fine. Okay, so now I'm just going to write this out. And again, you can do this step in your head. If you just want to look at what you wrote there in green and you just want to be like, okay, I'm going to multiply the 2 in, that's fine. You can definitely do that. I just always try and show all the steps when I'm doing them so that people don't lose what's happening. All right, so here you see now minus the whole numerator. And I'm putting it together as one fraction. Okay, that's important. And then plus, now it's just 1 times x minus 1. So I'm just going to say x minus 1. And that is then all over this LCD. Okay, we're going to keep going. You guys will just stop me if I maybe do something wrong. You're not following what I'm doing. So I'm just multiplying that negative 1 into that bracket, and then I still have my plus x minus 1. And that is still all over this LCD. All right, now obviously we have like terms, so we do need to collect them, add and subtract them. So we have 2x squared minus x squared, that is just x squared. We have 2x minus 2x plus x, that's plus x, right? And then we have a plus 2 and a minus 1, that's a plus 1. Oh, how lovely. Can we see what's going to happen? It's going to cancel out that trinomial bracket at the bottom. Again, if it makes you feel better about cancelling out something that is now multiple terms, you can put brackets around it. And guys, I'm just going to say again, we can cancel out these 3 terms with this bracket because the 3, we're not cancelling them out separately, if that makes sense. Right? We can't take this x squared on its own and cancel out that x squared on its own, something like that. All right. If you can cancel out all of the terms at the top with a bracket or something at the bottom, then you can do that. Okay. And then the answer is 1 over x minus 1. No. Yes.
Can you keep the x minus 1 in the bracket?
Yes. Absolutely. You can keep it in brackets if you want to. Nothing wrong with that. Any other questions? How are we feeling? Not sure if it's just tiredness or absolute tired. Okay, guys, we are going to now finally do one that is actually a compound fraction. Okay, are we ready?
No,
No, these are just fractions. We're just adding and subtracting. What do you mean?
give it us both.
Sorry.
Then why did we start?
But that's what they do in the book. Okay, I apologize on behalf of the art series. It's just how it happened. Now I must just check quickly how many lines I'm gonna need. If you want to do that, anytime you can do that.
No, this Ray's done enough petitions.
No, that was not real.
Don't do another petition.
All right, that is the numerator. I will tell you now what that is in case you can't read it. All right, next focus, please. Thank you, thank you. So guys, in the numerator, we have y over x plus 1 plus x over y. And then in the denominator, we have 1 over x cubed minus 1 over y cubed. This is now a compound fraction. You guys see we have fractions within the fraction. Now, what I would like for us to do, is to try and get rid of those little fractions as quickly as possible. All right? Unless some of you really love working with fractions, there are other ways in which you could do it, but I always teach my classes, we are going to try and get rid of those fractions as quickly as possible. Now, what we're going to do, guys, we are going to multiply, and this might seem at first like, why are we allowed to do it? So I'll explain. We're going to multiply the top and the bottom of this fraction by the same thing. Because when you multiply by something over itself, what are you actually multiplying by? 1. All right. So if I decide to multiply the top by 2 and the bottom by 2, I'm actually multiplying by 1, right? Because what's 2 over 2? Just 1. And you can multiply anything by 1 anytime you want, because that doesn't change the value of it. All right. So I must now think, what should I multiply the top and the bottom by? We want to do an intelligent multiplication so that it will cancel out, it will get rid of all 4 of those denominators of the inner fractions that I have. I listen to you now, Joshua. I just want everyone to think about it for a second. I'm going to repeat what I said now. Just look at what is written down there. You can look in your book. I want to multiply the top and the bottom by the same thing, so that I'm essentially multiplying by 1, which I am allowed to do. But I want to multiply by something that will cancel out, that will allow me to get rid of x and y and x cubed and y cubed all at once. Yes.
We do the same thing with equations. We just multiply every term by zero. So
Yes.
it's x cubed.
Yes. How do you remember on Thursday when we did equations with fractions? I say to you, let's get rid of all these denominators by multiplying every term by the LCD of the fractions that we had. We're going to do the same thing here. We're going to look for the LCD of the 4 denominators that we have. We're going to multiply the top and the bottom by that LCD, and then all our denominators are going to go away. So I'm going to write on the side times top and bottom. I want to check if that's on the screen. Yes. By LCD of, I'm going to say the smaller fractions. I suppose you can call them the inner fractions if you want. There's no real term for fractions with inner fractions. Right, we are going to multiply the top and the bottom by the LCD of the smaller fractions. Okay. And what I want you to do is please put brackets around the numerator and brackets around the denominator. Because now when I multiply the top, the numerator, by something, how many terms do I have in the numerator? 3 terms. So I have to multiply all 3 terms in the numerator by that thing. Okay, which is why I'm putting brackets around it. The same thing at the bottom. At the bottom, I have 2 terms. If I now decide to multiply the bottom, the denominator, by something, I have to multiply both terms by that thing. Okay. Now, guys, Josh already said it, but can we see that if we have x, y, and x cubed and y cubed, the LCD is x cubed, y cubed. I'm going to say that again. We have x and y and x cubed and y cubed. Remember, the LCD is something that all 4 of those denominators can divide into. So like I said in class on Thursday, we need to take all of the variables that are there, so x and y, but also to their highest exponents. So that all 4 of these can divide into the LCD. All right, so the LCD is x cubed, y cubed. I'm just going to write here the LCD is x cubed, y cubed. Again, you don't have to write it separately. I am just doing it because it's the first example of this type that we're doing. Okay, now I'm going to write here times by x cubed, y cubed. Times by x cubed, y cubed. Again, guys, I'm multiplying the top and the bottom by the same thing. So essentially, I'm multiplying this whole fraction by 1. I'm just doing it in a clever way. All right, I'm multiplying it by 1 in a way that it will get rid of my denominator. Okay, I hope that makes sense. I'm just speak up if it doesn't. Okay, please. Now we're going to say y over x times x cubed y cubed. Now, I don't know if you guys can just do that in your heads. All right, I will do it quickly just so that you can. So let me actually leave a line open. I want it to be too squished. Now this step that I'm going to write down, you don't have to show, guys. I'm just going to show the actual multiplication of each term separately. All right, so for the first one, you have y over x times x cubed y cubed. All right, you're doing that. See what I'm doing? I'm just writing it out. You don't have to. Okay, then we're doing plus 1 times x cubed y cubed, which is just x cubed y cubed, plus the third term times x cubed y cubed. All right, so x over y times x cubed y cubed. Again, you don't have to write that step down. I'm just showing that I'm multiplying all 3 terms of the original numerator by x cubed y cubed. And we're going to do the same thing at the bottom. So we have our 1 over x cubed that we're multiplying. So I'm doing this now, right? We're multiplying by x cubed y cubed. And then minus the second term 1 over y cubed that I am multiplying by x cubed y cubed. Again, you don't have to write that step down, okay? Especially not if it's confusing you. I hope it's not. I'm just literally showing each term multiplied by the alphabet. Now guys, here we have a y that I'm going to times by y cubed. What's that going to give me? Y to the 4. But let's look at these x's. Hey, I have an x at the bottom and 3 x's at the top. So the 1 x at the bottom is going to cancel out one of the x's at the top. So I'm going to be left with x squared y to the 4. Does that make sense? Now, like I said, guys, if you can just look at this and do that multiplication in your head, perfect. Then you can just write that down. Plus, we already did the second one because it was an easy one. It was just 1 times the LCD. So that's where that one is coming from. X cubed y cubed. Plus, now we see that we have x times x cubed. That's x to the 4, right? And then we have a y at the bottom and a y cubed at the top. So that is going to give me y squared. I'm just pausing so that everyone can absorb that. What do we notice? Hopefully we are noticing that we now no longer have smaller fractions within the numerator. Okay, the numerator is now these 3 terms, where we started with these 3 terms. Okay, all over. Now the denominator is a bit easier to do. We have 1 over x cubed times x cubed y cubed. The x cubes are going to just cancel out, right? I'm going to be left with y cubed. Minus, here the y cubes are just cancelling out. I'm left with x cubed. Now guys, to me it kind of looks like we need to factorize. Okay, just to make sure, maybe when we factorize the top and we factorize the bottom, there is something that can cancel out. Okay, this is also what I said in class on Thursday. When you have put everything together as one fraction, now it was given as one fraction, but we've simplified it, right? In the sense that they are no longer smaller fractions. But for us to simplify this, we need to do some factorizing. Now, what can I do at the top there? Take out x squared y squared, is that right? Okay. X squared y squared. Okay, then let's see what's left from the first term. I will be left with y squared plus xy, right, plus x squared. Okay, so I'm just taking out a common factor there. What do I have in my denominator? The difference of cubes. Good. So remember when we do a difference of cubes, we end up with a binomial and then a trinomial. The binomial is the cube roots of these 2 terms. So the cube root of y cubed is y, and the cube root of negative x cubed is negative x. And then we use our binomial bracket to get the trinomial. So we say the first term squared, so y squared. Then we multiply them, negative xy, but we now just change the sign, remember? And then we need to square the second term. Negative x when we squared is positive x squared. All right, and now we notice that yes, in fact, we do have the same bracket at the top and the bottom. So I am left with a final answer of x squared y squared over y minus x. How are we feeling? Hmm? You just need to take it slow, guys. You just need to write down all of your steps. Try not to skip steps, just, just because you're rushing. Try and just do this step by step. Okay, I'm going to give you a couple to practice on your own. Tomorrow in school, we are going to practice more fractions like the first two. Right, so I'm not going to give you homework like those ones now. I'm just going to give you some compound fractions for homework. So this is exercise 1.4 in the AP textbook. The exercise starts on page 6, but the questions that you must do are only on page 7. And I want you to do number 3.
How many questions are you?
No, you're not doing all of number 3. I'm choosing something to do. Let's say C, and just one more, I promise. And E. Okay, so 3 of these guys. Yeah, I just don't know if it's organized first, but I think okay. Okay, did you all write that down? 3, B, C, and E. Yeah, it's a bit small, so I don't know. I need to see if I can keep some in. Okay, guys, it is that one, and that one. Yes.
Then I will like
Everything minus square root.